Hey guys, this is Carrie, and in this video we're going to be doing the answer key for homework number 4. So let's take a look at problem number 1. We've got a triangle in the complex plane right here, and it looks like similar to class, we're going to be trying to guess where this triangle ends up after different things happen. So each point in the image above is multiplied by I 12 times. What quadrant will the image land in? So one way to do this is to actually count it. We know if you multiply by I once, that's the same thing as a 90-degree rotation. So if we multiply by I 12 times, that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Gets right back to where it started. But you might think, is there a better way to do that? And yeah, there actually is a better way to do it. Instead of counting these individually, you can actually think about, well, if multiplying by I once is a 90-degree rotation. If you multiply by I 4 times, 1, 2, 3, 4, that's going to be a 360-degree full rotation. And so because one full rotation takes 4 times, if you do 12 divided by 4, you see that this is actually 3 full rotations with no remainder, no decimal. And so that means that if we do 3 full rotations, let me change colors again. Wow, this is getting really sloppy, but it's okay. 1, 2, 3 full rotations, it brings you right back. Oops, I'm putting it in the wrong spot. It brings you right back to quadrant 2. If you multiply every point in the image by I 13 times, then what quadrant will you be in? Well, we saw in the problem before that multiplying by I 12 times does 3 full circles. So if we have 13 times, that's going to be 3 full rotations, but with 1 leftover rotation. So that 1 leftover rotation is 90 degrees, and it will put us in quadrant 3. Which of the following best describes what happens when the image is multiplied by I 66 times? So for 66 times, what we can think about is, because 4 rotations makes a full 360-degree rotation, we could say 66 divided by 4 is equal to, let's see, 16.5. And so since 66 divided by 4 isn't very nice, if you do a similar number, 64 divided by 4, you'll see that that's 16 exactly. So we have 16 full rotations, but because 66 is 2 off from 64, we have 2 remainder 90-degree rotations. So we've got 16 full rotations, 2 remainder rotations. It looks like that's answer choice 4. Each point in the image is multiplied by I 200 times. What quadrant will the image land in? Well, if we do 200 divided by 4 to calculate the number of full rotations, that gives us exactly 50 full rotations. If we do 50 full circles, that will leave us right back where we started, so it will be quadrant 2. Each point in the image above is multiplied by I 203 times. What quadrant will the image land in? Well, we saw that 200 times creates 50 cycles. So if we did our 200 times, it's going to put us back here 200 times. But for 203, we've got an extra 3 rotations. And so with those extra 3, that's going to put us 1, 2, 3. It's going to put us in quadrant 1. I'm going to leave question F for you guys to figure out. Try to use some similar ideas. Okay, question 2, write the value of each of the following. So there's a number of ways to do this. You can think about all these things algebraically, but my favorite way to do it is to think about them graphically. So I'm going to draw a complex plane, and I know from the work we've been doing in class the last couple of days that the answers to all these questions will either be 1 on the real axis, -1 on the real axis, +1i on the imaginary axis, or -I on the imaginary axis. So in order to build this up again, using the same proof as class, you don't have to go through this if you really understand it, but since maybe you didn't get it the first time in class, it pays to go over. And we have I to the 0th power. One of the hints in class said anything to the 0th power equals 1. So I to the 0th power starts us off at 1. I to the 1st power, well, if you have anything to the 1st power, that's just that thing times itself once, which is that thing. So I to the 1st power will just be I. We know from class in the couple of zoo nows that we've had recently that I squared is actually, because I is the square root of -1, I squared will actually be -1. So here we have I squared is -1. So it looks like each time we increase the power of I by 1, it's looping us around in this order. So here was I to the 0th, I to the 1st, I to the 2nd. Now to get I to the 3rd, a good guess would be, I'm going to use blue for this guess, a good guess would be I to the 3rd is actually -I. Maybe it continues that looping cycle. But we had to put a question mark on this because we might not be sure. One way you can think about I cubed is I times I times I. I times I is I squared. I squared is -1. So we get -1I, which is -I. So our diagram agrees. So I'm going to erase the question mark. And then here for I to the 4th, using purple, you might assume, well, maybe it continues this rotation and brings you all the way back to 1. Let's see, I to the 4th is equal to I times I times I times I. I'm going to put that question mark that we put here before because it seems like it's following a pattern, but we need to prove it. So I squared times I squared. Well, I squared is -1, so we get -1 times -1. That's 1. So I to the 4th, what's going on here? I to the 4th is, oh, I don't know why that question mark is there. Okay, I to the 4th is 1. So we can now erase that question mark. I wish I could erase that question mark. I don't know why it keeps coming back. Okay, I'm just going to scribble over it. All right. I to the 5th continues the pattern, so if I to the 4th is back here, I to the 5th will be looping us around the second time, back to I on top. I to the 6th will be back around to -1, back around to -I, back around to 1, I, -1, -I, and you have that nice pattern that has to do with repeating the same thing in cycles of 4. Should remind you a little bit of repeating the same thing in cycles of 4. So let's see if we can use this to answer some multiple choice questions. I to the 44th power. So all of our rotations start off at I to the 0th power, which is 1. I like to draw this diagram anytime I do I to an exponent. So since I to the 0th power is here, and we start off here, that means that I to the 4th power, 3, 4, will also be here. So because 44 divided by 4 is 11, I see that it goes, I shouldn't have said all that all at once, sorry. Because 44 divided by 4 is 11, it means that it goes in 11 full rotations, the same as before. And so we have 11 full cycles, and if we have 11 full cycles with no remainder, it just keeps putting us back at the 1, and so this must be 1. What is the value of I to the 45th? Well, if I to the 44th brings us back to 1, then I to the 45th has 1 extra compared to this. And so that means that we'll have to go 1 extra cycle, not full cycle though, 1 extra 90-degree turn, which will leave us up here, and the value up here is I. So that's I. I to the 46th, well, that's just going to be I to the 44th was back here 11 times. So if we have 46th instead, that's going to be 2 extra cycles. That will put us at -1. Of course, another way to do I to the 46th was to think, well, if I to the 45th was I, then you could go 1 more from there, and that would put you at -1, and that would make 46 as well. I to the 47th, I'm going to leave to you guys, so you figure it out. I to the 666, I think we talked about in class, that's for you guys as well. Which of the following is equal to -1? So let's see. It looks like we have 111, 112, 113, and 114 all to consider. Well, I think the easiest one of these to look at is actually to start with 112. The reason why I think 112 is easiest to look at is 112 is divisible by 4. If you try to divide these, I think you get 28. And so what that means is, when you do I to the 112th, that's going to be start at 1, and you create 28 full cycles. In order to get to -1, let's see, I don't want to do 28 full cycles. I'd like to do 28 full cycles with 1, 2 extras. So, with 2 extras, well, this is 1 too few. This is 1 extra, 113 from 112. this one is 112, which makes 28 full cycles, plus the extra 2 to get from 112 to 114. That's going to be I to the 114th power equals negative 1. All right, so Diana believes that the complex number graphed above is I to the 70th. Luke believes that this is the graph of I to the 174th. Who is correct? Oh man, okay, so they're saying that this is I to the 70th or I to the 174th. Well, I'm going to do 70 divided by 4 to count how many full cycles this is. 70 divided by 4 actually doesn't work out too nice. It gives us 22. Is it 22? No, I'm wrong. Oh my gosh. Sorry, guys. I have to actually work on my division skills. All right, so 68 divided by 4 is 15 plus 17. And 0.5. 17.5. You could have used your calculator. That you don't do it in your head. I should have done that all along. 17.5. So it looks like we're going 17 full cycles. And because 0.5 is a half, we're going 17 full cycles plus an extra half cycle. So 17 full cycles would bring us here, but then we have an extra half cycle, which is a half turn, 180 degrees, which puts us there. So that's good. So Luke is, Diana's right. Let's see about Luke. So Luke says 174 divided by 4. Let's see what that is. Oh my gosh. 100 divided by 4 is 25. That's 15. That's 42. Oh my god, I have to use my calculator to do this. Put myself on the spot. 174. No, 174 divided by 4. Oh, 43.5. All right, let's see. That's 43 full turns. Plus an extra half turn, because 0.5 is a half. So even if we went 43 times around and then an extra half, it puts us in the same spot. So Diana is right. Luke is right. Everyone's right. Great. Happy. Awesome. These last two are kind of challenge questions for you guys to think about. I'm going to leave these for you to figure out annoyingly, even though I'm sure you guys will be pissed off and ask me about question 11 because of the coefficients. I want to see if you can figure out how